My name is Tim Lenton. I'm a professor of Earth System Science at the University of Exeter. Welcome to my exp. So tipping points are something that can happen in a whole range of complex systems, including the human body and the whole Earth's climate system or Earth system. A tipping point is where a small nudge to a system has a huge outcome. It changes the state or the fate of that system. I suppose you could say that a heart attack or death were the most bleak tipping points for the human body. But in the Earth's climate, there are many parts of the planet that have this extraordinary capability that under the right, or you might say the wrong conditions of forcing, we would say, so it could be human-caused global warming or something else driving the climate, some bits of the climate system can be tipped into a different state. So there are a whole range of potential tipping points in the Earth's climate system that human activities, global warming that we're causing now and for the rest of this century, could potentially tip them. Some of these systems are icy. They include the great ice sheet on Greenland, on West Antarctica, and parts of the East Antarctic ice sheet. Some of these tipping points involve the biosphere, the possibility that we could tip a dieback of the Amazon rainforest or of the great forests that cloak the northern high latitudes, the so-called boreal forests, or a major loss of coral reefs in the tropical oceans. And finally, there's a third class of tipping points which would involve reorganizing aspects of the circulation of the ocean and the atmosphere and how they're coupled together. So a famous example of that would be tipping a collapse of what's called the overturning circulation of the Atlantic Ocean, which includes at the surface what we know as the Gulf Stream that keeps Western Europe relatively mild in climate. So, like any complex system, the parts of the Earth system are interconnected. And that's true also of the climate tipping points that I and others have identified. We know, for example, that as the Greenland ice sheet is melting and fresh water is pouring into the North Atlantic Ocean on either side of Greenland, that this makes the surface waters of the ocean there less dense, less salty, less prone to sinking to the bottom of the ocean, which is what happens on either side of Greenland, this extraordinary process we call deep convection of ocean waters. And it's that deep convection that propels what we call the Atlantic overturning circulation. So the Greenland melt is expected to and appears to already be weakening the Atlantic overturning circulation. So as the global temperature increases with human-caused global warming, we expect the likelihood of particular tipping points to be crossed to increase. And we have some evidence that would be the case. That what's alarming is we're currently at about just over 1 degree centigrade of warming, and we're already seeing strong evidence that we might have tipped part of the West Antarctic ice sheet into an irreversible retreat. It drains enough ice to raise the global sea level by over 1 meter, And if that bit of the ice sheet goes, physical models of the ice sheet suggest that the other parts of the West Antarctic ice sheet would eventually collapse, and that would give a full over 3 meters of sea level rise. We have the same dynamics, as scientists call it, going on for part of the East Antarctic ice sheet, where again it's hard to rule out that we aren't already at a tipping point for a part of East Antarctica draining what's called the Wilkes Basin. And we also can't rule out that the Greenland ice sheet, which is melting at an accelerating rate, we can't rule out that it's shrinking irreversibly. So we might have already made a commitment on the long term to 10 or more meters of sea level rise. The only comfort at the moment is it's unfolding slowly and would take over 1,000 years for all that melt to happen. But the more we warm things up, I'm afraid the faster the ice sheets melt.